A pyramid has one polygon base and one vertex. Here's an example of a pyramid. The lateral faces are triangles with a common vertex. So the common vertex on this pyramid is V. They all meet at point V. The altitude is the segment from the vertex perpendicular to the base. So in this example, we have the point V and it goes straight down to the middle of the base, and you see the little right angle mark. The height is the perpendicular distance between the base and the vertex. Here's an example of a regular pyramid. A regular pyramid has a regular polygon as its base. Regular pyramids have several important properties. All the lateral faces are isosceles triangles. The slant height, or cursive L, of the pyramid is the length of an altitude of a triangle that is a lateral face. So you'll notice on this diagram, the little cursive L is pointing to the slanted line, hence slant height. All lateral edges are congruent, and the altitude of the pyramid meet at the base of the center of the base of the polygon. So notice the altitude is my height. Okay, my vertex, point V, is the vertex of my pyramid. Base, pentagon PQRST, is the base of the pyramid. Lateral faces and edges. The lateral faces of a pyramid are triangles. The segments in which the triangles intersect are the lateral edges. So for instance, TV is a lateral edge, SV, RV, QV, and PV are all lateral edges. Altitude is the segment from the vertex perpendicular to the plane of the base that is the altitude of the pyramid. The height is the length of the altitude, so it's how tall it is. My slant height is the height of a lateral face of a regular pyramid, so SV could be a slant height. Now, the lateral area of a regular pyramid equals half the perimeter of the base times the slant height. So my lateral area is 1/2 times the perimeter of the base times the slant height. LA equals 1/2 times perimeter of the base times the slant height. Now my surface area, or the total surface area, of a pyramid is its lateral area plus the area of its base. So my surface area is LA plus B. Now notice in our prisms that we talked about, we have two bases. They're parallel, they're the same shape. So for instance, a triangular prism, you have two triangles with a bunch of rectangles connecting it. So your formula was LA plus 2B because you had two bases. Well, this time you chopped off one of the bases and made them all come to a point. You have just one base. So here's an example of a regular square pyramid. Notice the slanted line down is my slant height, and we normally notate that with a cursive L. We can also talk about the base edge, and the other dark blue line is the height. For the first example, we're going to look at a regular square pyramid. My base edge here is 10. And also my lateral edge they gave me was 13. Okay, my lateral edge is the slanted edge. So I know that I can look at this triangle here that I'm outlining with the mouse. So that's 5 squared plus my slant height squared equals 13 squared. This is a special right triangle. It's one of our Pythagorean triples, but we also need to break it up and look at all these different right triangles. So this one, I know from my Pythagorean triples that my L is 12, my slant height. So I can go ahead and plug that in. Next, I'm looking for the height. So now that I know this is 12 and this is 5, I can use Pythagorean theorem to get the height. So here's my triangle that I'm looking at now. I know that this one's 5 and this one's 12. I can use Pythagorean theorem to get the height. And that tells me the height is 119, square root of 119. Okay, to find my lateral area, it's 1/2 times the perimeter of the base times the slant height. So 1/2, the perimeter of my base is 40 because the side length is 10 times 4, 40. And my slant height we found out was 12. We found out our slant height was 12. So I'm left with 240, and here my units are inches squared. Okay, so the surface area is lateral area plus 1 area of the base. So that's 240 from before. The area of my base is a square, so it's just going to be 10 squared. So you get 340 inches squared. To find the surface area of a regular hexagonal pyramid, we have the base edge 10 centimeters and the slant height 14 centimeters. Remember, we like hexagons because we can use 30, 60, 90 triangles. I'm going to go ahead and draw. Okay, so this is my hexagon. I know that the base edge is 10 centimeters. So right away, I know that the perimeter of the base is 60 centimeters. Now I'm going to look at the inside because remember I need to make that triangle inside of my hexagon. So I'm going to draw my right triangle. Okay, they told me the side length was 10 centimeters. So I know that half of that for my triangle would be 5. Now this is a 30, 60, 90 triangle. So if my short leg is 5, I need to multiply by the square root of 3 to get my long leg. Okay. So now I can find the area of the base. So the area of my base will be 1/2 apothem times perimeter. So that would be 1/2. My apothem is 5 square roots of 3, and my perimeter would be 60. So the perimeter of my base would be 150 square roots of 3. Okay, now I'm going to use that in order to find the surface area of my pyramid. So remember, the surface area of my pyramid is my lateral area plus the area of my base. I know the area of my base, but I have not found the lateral area yet. So I need to go ahead and do that. My lateral area is 1/2 the perimeter of the base times the slant height plus the area of my base. So 1/2. They gave me the slant height, which was 14. And I know my perimeter is 60. Plus the area of my base, that's 150 square roots of 3. So 1/2 times 60 times 14 will give me 420 plus 150 times the square root of 3. Now you cannot combine these. This one does not have a square root of 3, so you cannot combine these. You're stuck with it like it is. But let's go ahead and add our units. That would be centimeters squared. A cone is like a pyramid, but its base is a circle. We'll only work with right cones. So notice a right cone straight up and down, an oblique cones that kind of squish to the side. So the segment joining the vertex of the cone to its center is the altitude, or the height. The slant height, my cursive L, is the hypotenuse of a right triangle formed by the altitude and the radius. In a cone, the lateral area is half the circumference of the base times the slant height. So in essence, it's again perimeter of the base. It's again perimeter of the base times the slant height. The surface area or total area of a cone is the lateral area plus the area of the base.